Let's see how we can plan sample size for this big 5 vignette study, following the spirit of the a priori procedure. So as you can see here, I have the study designed, I have my ordering set up, I've even set up a data set here. All I need to do now is figure out how many participants to collect for the study. And also recall that what we're going to be doing here is running a pattern analysis, crossed orderings, and we're looking for the extent of agreement between the self and other ratings on, let's say, the extroversion vignettes. So an individual can choose extroverted, introverted, both, or neither, and then that individual's friend also rates that same person. So how much agreement is there between the two sets of ratings? So to determine sample size for this type of study and this analysis, we first need to set up a starting sample size. Let's just choose 100 to get the process going. And then if that's too low, we'll try another value and we'll repeat. We'll go through the steps again and again until we match up with our closeness proportion, which is the other value we need to determine using our closeness value. So let's use a closeness value of 5 here, plus or minus 5 for the PCCs that we're going to get. And then the closeness proportion, let's use 0.90 or 90%. So we want 90% of the randomly generated PCCs to fall within plus or minus 5 percentage points of the mean of those PCCs. So it's kind of like a precision index essentially. So to get the ball rolling then, we've got those values determined. Let's go ahead and select compute and generate random observations. And we have 100 as the default here, so that's what we're going to start with. We need 2 orderings, the extroverted, self, and other ratings. The data are discrete, or the observations are going to be discrete. There are 4 units to those observations. Again, extroverted, introverted, both, or neither. And then we don't need to add a constant to the numbers that we're going to generate here. The numbers are completely arbitrary. They're just placeholders, basically. Now, the data, again, are discrete. So we have 3 options we can choose from here. The normal distribution doesn't make any sense with only 4 options. The uniform option will create equal proportions of extroverted, introverted, both, and neither results or observations. I just don't think that's going to be the case with the actual data. Instead, I think the neither option is going to be chosen infrequently. The both option might be chosen a bit here and there, but I think most of the individuals are going to choose the extroverted or introverted options. Now, how they're ultimately paired, whether the self and other agree or not, that's a different question. That's the inference we're ultimately going to test with our analysis. So I think the data then are going to be distributed in a manner that might look like this for each ordering. So let's go with, let's say, 40% for the extroverted ratings. And again, the unit values here are just arbitrary. We'll say this is extroversion, introversion, both, and neither. And let's set up 40% as well for the introversion. And then for the both, there may be some ambiverts out there, so I'm going to set that up as 15%. And notice I'm summing up here. I'm up to 0.95. I need to get a value that's 1.0 or 100%, so I'll make that 5%. So very few people, only about 5% will choose the neither option. So now I've got that summed to 1. So this is the distribution for the ordering here. So I'll select OK. And we'll select OK to run it. So here we get the 2 randomly generated orderings. Let's go ahead and take a look at their distributions. And sure enough, looking at the numbers here, I have 40 zeros, 40 ones, 15 twos, and 5 threes. And I could go through and change the labels here to extroversion, introversion, but that's really not necessary. I know what the values here represent, and so I'll select OK here. And now we can run the analysis. So again, we'll select analyses and pattern analysis and crossed orderings. I'll move those over, and again, we'll assume those are the extroverted self ratings here, the extroverted other ratings, define the pattern. And this is what we are hoping to see with the data. I'm going to change the color here just so we can see the numbers. Let's go and take a look at the observations while we're here. And sure enough, they do look fairly randomly spread throughout the contingency table here, but with fewer cases in the neither option compared to the other options. So I can go ahead and select OK. And we need the randomization test, save those randomization tests, and select OK to run it. Iterates through, and we get a new data set created here, the randomized PCC. So I'll go to that data set now. Here they are. Need to get the mean of these PCCs, so I'll select Analyses and Descriptive Statistics, orderings, we'll move the PCCs over, get the mean, select OK. The mean turns out to be 34.36. I'm going to use that value, so I'm going to move this over so I can see it and remember it. Now let's go to the Define Orderings window, look at those PCCs, and I'm going to quickly, just using auto generate here, just create 3 units that I can edit and work with. It's just a little shortcut here to create 3 units that I can work with. So let's start with this middle unit here. And so 34.36, remember our closeness value is 5 or 5 percentage points because it's PCC is the index here. So 34.36 minus 5 is 29.36. And that goes up to 34.36 plus 5, which is 39.36. And so this is going to be, I'm going to go ahead and expand this out a bit so we can see the labels. So this is going to be our closeness value, or range if we want to call it that, because it's plus or minus 5. And then now we need to make sure we don't have any overlap. So I'm going to 20 is the minimum. I'm going to use that as the minimum. And now we want this to go to 29.35. These are the lowest of the PCCs. And then for the high ones here, 47 was the max and 39.37. Okay, now we are set to look at the distribution. Okay, looks like I've got some overlap here. Notice this error. I'm going to expand this out. So a negative value indicates some kind of overlap. So I'm looking how I have things defined, 29.36. That actually looks good. So what's happening here is there's some overlap probably because of the decimal. So I'm going to change this to 2 and go back, and that fixed it. So it was only looking at whole numbers, and so it was seeing some overlap there. It wasn't registering the decimal points that I'd placed in the definitions. And so by changing the number of decimals there to 2, that takes care of it. So now we don't have any overlap. Everything looks good here. All the PCCs are accounted for. We can take a look then at our closeness range. 740 of 1,000, that's 74%. So that's not high enough. What we want here are 90% of the PCCs falling within that plus or minus 5 range. So the sample size of 100 is not quite there. So we need to run through this process again, boosting the sample size up to, let's say, 200, and then hopefully we'll get something closer to 90% here for our closeness range, which of course is based on the closeness value. So this is following in the spirit of the a priori procedure.